summation and series. Begin. Now here the first thing that you see is how to write in general the sum of some general terms. If there are some general terms, how will you write its sum? That is given as sum over n un. What is un? Un is un is the general term. So here you can write un is nothing but the general term. Okay, it can be anything, like for example xn, n x to the power n, or x by n, something, anything. Okay, now if you are given un is equal to x plus iy, then how can you write the sum? Sum is nothing but s is equal to sum over n equal n. Okay, n to we don't know what is the limits. Okay, so sum over x plus iy, right? Or here you can write exn to the yn. Each term you are adding. So how can you write like this? Sum over n xn plus I times sum over n yn. This entire term, if you can write it as x plus I times yn, this entire term you can write it as capital Y. So this is how you can write the sum of n terms. Now coming to one example, here s is given as 1x x square x to the power n. So x to the power 3. So this is of the form x to the power n, where the first term is equal to x to the power 0, second term x to the power 1, etc. Then you can write the sum. Sum is nothing but s is equal to sum over n equal to, it starts from n starts from 0 to it goes to infinity times x to the power, or sum of x to the power n. Okay, similarly here you have another example. Oh wait, this is the same example. Okay, remove this x 1, remove this 1. Then let us see, here you have x square x cube. Now this is of the form similar x to the power n, but here there is a difference. What is the difference? Here it starts from x, that is x to the power 1. So you have to write n equal to 1 to infinity. Your 0 has gone, so it starts from 1 to infinity x to the power n. Okay, limits have changed. Now here you have the third case, where you have 1x. Okay, so this is of the form you can write here 1. This is also you can write 1 factorial, right? Sorry, here you can write 0 factorial. This is 1 factorial, 2 factorial, 3 factorial. So 1 divided by 0. So x to the power 0 by 0 factorial plus x to the power 1 by 1 factorial plus x to the power 2 by 2 factorial. It goes on. So this is of the form x to the power n divided by n factorial, right? So what will be the sum? S is equal to sum over n equal to, from where it starts, from 0, so 0 to infinity. 0 factorial equal to 1. Okay, 0 factorial equal to 1. Now coming to arithmetic progression. The terms, how will you write the terms of an arithmetic progression is a, the first term, then the second term would be a plus d, third term would be a plus 2d, and etc. up to the last term will be a plus n minus 1. Last term means nth term would be a plus n minus 1 d. This is not there. A plus n minus 1 d. Okay, so this is the last term. That means nth term would be equal to a plus n minus 1 into d. Now okay, this is the last term. What is the last term? A plus n minus 1 times d, that is equal to we denote it by an or sometimes by tn also. Now sum of n terms, how will you write the sum of n term? Sn is equal to n by 2 times a plus an last term, or another formula is also there, Sn equal to just split, rearrange an. Rearrange means write what is an here. An, you will get n by 2 times, sorry, this is not capital N, this is small n, number of terms, n by 2 times 2a plus n minus 1 into d. Fine. Okay, so from this you need to remember only these things. To geometric progression. Geometric progression, the terms, how will you write the terms? First term will be a, then second term will be ar, third term will be ar square, and it goes on. Now what is the a? A is the first term, and what is the r? R is called the common ratio. Sometimes this r can have two values, either it should be less than 1 or r can be greater than 1. Okay, just remember this, we may use this condition later. Okay, now this arithmetic progression is an infinite series. It's an infinite series, while arithmetic progression is finite. Arithmetic progression is always a finite series. Now why? Because there must be some end to the arithmetic progression, but here there need not be an end. Okay. Now what is this common ratio? Common ratio is nothing but the nth term divided by n minus 1th term. Okay, this gives the common ratio. Now how will you write the sum of here you don't need the last term, okay, but sum of n terms we require, but you will remove this. Now how will you write the sum? Sum is sum over n equal to 1 to infinity a, which is the first term, r n minus 1. Now this is considered as the last term in the series n. Okay, now Sn is equal to a times 1 minus r to the power n divided by 1 minus r if r is less than 1. This is where you use that condition. Sn will be equal to a times 1 minus r to the power n by 1 minus r, where r is less than 1. Similar is a times r to the power n minus 1 divided by r minus 1 if r is greater than 1. Mode of the value r should be greater than 1. Okay, now there is this is for sum of n terms. If there are infinite terms, then S infinity, that means infinite number of terms, A divided by 1 minus R. This is the formula. All these three formulas must be remembered. Important, we can put it as important. Usually for arithmetic progression you don't consider having a finite number, but these are the answers for the sum of finite terms. If n is finite, you can use these two formula, and this is for infinite terms. Okay, now here we have one problem, 1 plus x square plus x cube. So how we can this is extending up to infinity. Now what is the first term? A is equal to 1, and what is the common ratio? R. Common ratio R equal to x. So immediately we can write S infinity is equal to A divided by 1 minus R. And what is A? A is nothing but the first term, 1 minus x. 1 divided by 1 minus x, that is the S infinity. Now this is for now we have seen this is for x mod x less than 1. Okay, so you can write in this way: sum over n equal to 0 to infinity, x to the power n is equal to, x to the power n means the first term would be what? The first term would be here the first term is what? First term is 0, sorry, first term equal to 1. So this is similar to, not similar, it is same as our series. So you can write sum over n equal to 0 to infinity, x to the power n equal to 1 divided by 1 minus x. Please remember this. This is very important formula. This we would be using in EMT as well as statistical mechanics. Yes, here is one such examples that we are using in statistical mechanics. Z is equal to sum over n equal to 0 to infinity e to the power minus n times beta e. Beta is nothing but half kbt. Okay, beta e. So how will you write this formula is, I am just rearranging and writing it in a different way. N equal to 0 to infinity e to the power minus beta e whole to the power n. So this is similar to our previous example, n equal to 0 to infinity e to the power x to the power n. What was the answer we got? 1 divided by 1 minus x. Now here what will be the answer if z is given as this? Now what is this z? Z is nothing but partition function. Partition function. Partition function is defined for group of particles in an energy E. Okay, fine. 1 divided by 1 minus x. So here it will be 1 divided by 1 minus x. What is the x? This is x e to the power minus beta e. Now here you have the second question. Sum over n equal to 0 to infinity e to the power minus beta e. This is same, but what is e? E is given as n plus half h cross omega. Now immediately once you get the question, you start writing sum over n equal to 0 e raised to minus beta. E is nothing but n plus half h cross omega. Right. Now bring this together. Sum over n equal to 0 to infinity e to the power minus beta n h cross omega into, instead of plus adding here, I am writing another term, okay, plus half h cross omega times beta. Fine. Beta half h cross omega, both terms are included. Now this beta h cross omega is a constant, half beta h cross omega, because n is the only variable here, n equal to 0 to infinity. So bring that outside, e raised to half beta h cross omega sum over n equal to 0 to infinity. This I will write it as e raised to minus beta h cross omega whole to the power n. Fine. Now this entire term is nothing but sum over n equal to 0 to infinity x to the power n, that is equal to 1 divided by 1 minus x. So e to the power okay, one minus sign will be there, this minus, okay, yeah, minus half beta h cross omega into 1 divided by 1 minus x. X is nothing but e raised to minus beta h cross omega. Now can you tell me what is this energy n plus half h cross omega, of which model n plus half h cross omega? Here we have n equal to 1 to infinity. Now let us write what our equation will look like, or summation will look like. E raised to minus beta, what is e? E is equal to h cross omega, so n h cross n equal to 1, so h beta h cross omega, this is our first term, plus e raised to minus 2 beta h cross omega, the next term is n equal to 2, plus e to the power minus 3 beta h cross omega, and it goes on up to infinity, right? Now this is of the form x to the power 1 plus x to the power 2 plus x to the power 3, etc. So here x to the power 0 is missing, 0 is missing, so this is of the form there is no 0 but all other is there. So this is a geometric progression with a x to the power 1, it goes on like that, right? So the first term, what is the first term here? X, so that is x divided by 1 minus x, that is the nothing but s infinity, that is infinite terms. So if you want, you can write in this side n equal to 1 to infinity, 1 to infinity x to the power n is equal to x divided by 1 minus x. Okay. We are going to take the derivative of the equation that we know, that is sum over n equal to 0 to infinity x to the power n. This equation is 1 divided by 1 minus x, because our first term here is n equal to 0, so n becomes 0, so our first term is 1. Fine. Now when you take the derivative of this equation, what you are going to get is sum over n equal to 0 to infinity n x to the power n minus 1, n x to the power n minus 1, that's equal to minus 1 divided by 1 minus x whole square into the derivative of this, that should be the coefficient of x, that is minus 1. Now that also we can write it as 1 divided by 1 minus x whole square. Now what we are going to do is, we are just trying to write, since I cannot put n equal to 0 because this the first term will become 0, so I am writing it in the form of making it 1, sum over n equal to 1 to infinity n x to the power. Now when I changes n 0 to 1, here n I have to add 1, right? So it becomes n, that's equal to any change here, okay, so that's equal to 1 divided by again one mistake is there, divided by wait let's see, I think here we have to make, so sum over n equal to 0 to infinity n x to the power, let us write it as n x to the power n divided by x, n x to the power n divided by x, n x to the power equal to 1 divided by 1 minus x square. I think this equation is fine, correct? Just multiplying by x and dividing by x, it became n x to the power n, and then here. Now this is equal to sum over n equal to 0 to infinity n x to the power n is equal to 1 this x will go to left, so it becomes x divided by 1 minus x whole square. Yeah. Now since we cannot have n equal to 1 starting, we will write it as sum over n equal to 1, n equal to 0, here if you put 0 it will become 0, so it doesn't make any sense. So n equal to 1, instead of 0 you will put n equal to 1, n x to the power n is equal to x divided by 1 minus x whole square. So this is the answer. Sorry for that, forget about this step. So this is given as h naught. Okay, now this is falling from a height, that is initially it was at velocity 0 and it is coming down and it is falling here. Okay, so it has covered h naught distance. So from this as I said, you can write velocity when it reaches the ground will be equal to under root 2g h. This is nothing but from v square minus u square equal to 2g okay, v square minus u square is equal to 2g, instead of it is actually 2as, a is nothing but gravity acceleration 2gh, so u equal to 0, so you can write it as under root 2gh. Here you have to write it h naught indicating v naught, so this will be v naught, this will be v1, v2, v3 etc. Fine. Now what is given is E is given as V1 divided by V naught, which means V1 we know this is 2G H naught, right? Under root 2G H naught divided by under root 2G, sorry, this is H1, this is H naught, that is equal to E, coefficient of restitution. Now root 2G and root 2G get cancelled, so E you can write it as H1 divided by H naught under root, which is equal to E square. I can write it as H1 divided by H naught. Now from here I will get H1, that is equal to E square H naught. That means the height to which this ball goes up is nothing but H1, which is equal to E square H naught. Now can you tell me what will be equal to H2 in terms of H1? It will be equal to E square H1. Here you will get H3, which is equal to E square H2. Any doubt here, anybody? Yeah. Then this is E square H naught, this is E square H1, but again H1 is nothing but E square H naught, so this I can write it as E to the power 4 H naught. This I can write it as E square E to the power 6 H naught. Fine. Now the total distance covered will be, it's an infinite series, so from H, from here to here H naught, fine, from here to here H1, again from this point to this point plus H1, plus from here to here H2, again the same distance will cover plus H2, plus H3, again plus H3, goes on. Now that is equal to H naught plus 2H1 plus 2H2 plus etc. Now we know H naught as yes.
Can you explain how you write this H naught plus H1 plus H1 plus H2 plus H2? I didn't get that.
See here, ball is traveling from here to here, that is your first H1, okay. This ball will travel from this up to this height, that is H2. Again ball will come down, it will retrace the same path, so that is H2. But the next time ball will not reach the H2, it will reach H3, but it will again come down, which is H3. Again it will go up, which is H4. Again the same distance will come down, then it goes on. So from here H1 it traces first one time, but H2 it will travel twice because it is going up to here and coming back. In the beginning it was not going
yes,
up.
sir, got it, sir.
Yeah. So our equation is H naught plus 2H1 plus 2H2. This is why I said in the beginning, fall with the ball. That's how your CSIR questions will be. That goes on, okay. Now in terms of E, we will write it as H naught plus 2 times E square H naught plus 2 times E to the power 4 H naught plus again here it is 2 times E to the power 6 H naught, and it goes on, right. So in general you can write Hn is equal to E to the power n H naught 2n, E to the power 2n H naught. Yeah. So the sum, this is the sum. We are asked to find out the total distance sum. Okay, so I am taking this h naught plus 2e square h naught as 2e square h naught as the common 2e square h naught. Then what I will do, just add other things. This will be power, this is e power, this is square 4, then e to the power 6, it goes on, right? Yeah. Now here you consider what you want. This is first term, second term, third, fourth. So it goes on like this, e to the power 2n, right? That means your first term a is equal to 1 and r, the common ratio is e square. Then how will you write the sum? Sum is nothing but 1 divided by 1 minus r, because your first term is 1. So that you can write it as h naught plus 2e square h naught into 1 divided by 1 minus e square. Again, what you can do here is, you can take h naught as common, 1 plus 2e square divided by 1 minus e square you can do. This will be h naught into 1 minus e square, here you write, plus 2e square divided by 1 minus e square. Now what you can do is just the last step, 1 minus e square, and so this will be 1 plus e square divided by 1 minus e square. This is the total distance. Yeah. Now see here, the total time taken t, and let me write this capital T as t naught, that is the time taken from height h, this is height h, this from here to here, and the another line this again, and it continues to decrease and it finally reaches this. So this is t naught, this is t1, this is t2 and t3 and goes on. Now t naught will be traversed only once, but t1 will be twice, t2 also will be twice, t3 will be also twice, because it's going up this point and then coming back, right? So that's it. So t naught plus 2 times t1 plus 2 times t2 and it goes on, right? This is the series that we have got. Now in the former case where we need to find out h naught, we used the formula v square minus u square equal to 2as, but here we cannot use this because we cannot have the formula something like this, because time is to be found out. So what formula we will be using is this h naught is equal to ut plus half at square. So ut plus half at square. Now initial velocity of the particle is 0, so we need to go with h naught is equal to half a t square. Now our aim is to find out t naught, so that will be written as t naught. So 2 h naught and this a is nothing but our gravity g, and t naught, that is equal to t naught squared, but we need t naught, so this will be nothing but 2 under root 2 h naught by g. Now similarly what will be 2 times t1, that will be is equal to 2 into root of t1 is nothing but 2 h naught we have written, so this will be h1 divided by g plus 2 under root 2 h2 divided by g, and so on, it goes on. And here also we can write it as root of 2 h naught by g plus. Now next thing that we need to write is, we have to write this h1 h2 in terms of coefficient of restitution and h. So that will be equal to root of 2 h naught by g plus 2 times root of 2 h1 is equal to, from the previous class that we know, h1 is equal to e square h naught. So let me write that e square h naught by g plus, again you have 2 times root of 2 this h2. So that is h2 is equal to e to the power 4 times h naught. So e to the power 4 times h naught by g, and this continues. Right. Now again we can take e square from here outside, and let us write that root of 2 h naught by g plus 2 into let us bring this 2 h naught is square root of 2 h naught by 2 h naught by g within bracket. That means this 2 along with, except this e square, everything I am taking it inside in the bracket. So root of e square will be inside, right? Root of e square is nothing but e. Here you will have root of e power 4, that is nothing but e squared. Again in the next term it will be e to the power 3, and so on. Now here you see this is an geometric progression with the first term as the first term a equal to e, and the common ratio r is equal to e. Now this e value is always less than 1 because it is v by initial velocity, the upward motion velocity by the incoming velocity in the exam. For example, here if it is going down, this will be v, and if it is going, this is going up, this is u. So v will be always greater than u. Okay, this will be u by v. In this case it will be u by v here. Okay, so since it is always less than 1, we can use the formula for summation. Sum is equal to sum of n, the infinite terms will be is equal to a divided by 1 minus r. So here a equal to e and r is equal to e, so it will be e divided by 1 minus e. Now what you can do is, you can see this is two common thing that you can take it out, under root 2 h naught by g into 1 plus 2 into, now what we got, the entire term of the GP is the sum, right? E divided by 1 plus e, e divided by, sorry, 1 minus e. Now this will be equal to 2 h naught by g into, this one you can write it as 1 minus e plus 2e divided by 1 minus e. So 1 minus e plus 2e, that can be written as 1 plus e. So root of 2 h naught by g into 1 plus e divided by 1 minus e. I hope this is clear. See, what do you mean by coefficient of restitution means, now ball is falling from a height h, okay, h naught, it's hitting the ground, and here you will have the maximum velocity of the particle, that is, let me call it as v. Now after hitting some of the energy will be transferred to the surface in the form of vibrational energy, and also sound. Both are same thing, but some sound we cannot hear, so vibrational energy. So once it goes back, it will be going back with lower velocity. If it was an elastic collision, both in the velocity of incident and the velocity at which it is moving away will be same, but it is not elastic collision. Since it is inelastic, this velocity u will be a little smaller, so u by v will be always less than 1. This is for inelastic case, and this u by v ratio is called the coefficient of restitution. Fine. Taylor series is a function f of x at some point a. This is to be defined in terms of series, some series. So it is always expressed, or the expansion is done at a point a. We can write some variable x equal to a. Okay, now it can be, point can be anywhere where the function f of x has the availability, or the if the function is defined in the interval minus 10 to plus 10, it can have any value between minus 10 to plus 10. Okay, yeah. Now the conditions we need to follow are this: for expanding are the function should be continuous. One is that the function should be continuous. Now how to write whether the function is continuous or not? It's a limit at x tends to, so we define at a point a, right? So a plus, that means just a point ahead of a, f of x. That means when for example, if it is a is 1.1, it should be equal to limit x tends to a minus f of x. At these 2 points it must be equal, so then it is called a continuous, and derivative must exist. Derivative points should be there. That means limit x tends to a minus f dash of x should be equal to limit x tends to a plus f dash of x. These two conditions must be followed. Now these are similar to analytical function, complex numbers. It is very important. Analytical functions. Okay. From analytical functions, usually 5 plus 3.5. Two questions will come, one from C part and one from part B. Okay, now let us see how it is being expanded. Expansion at what is the point? X equal to a. X equal to a for the function f of x, or the expansion of the function f of x at x equal to a. So how can you write that? F of x is equal to f of a plus x minus a by 1 factorial into f dash of a, then plus x minus a by 2 factorial, this x minus a whole square into f double dash of a, plus the third term you could guess, x minus a whole cube by 3 factorial into f triple dash of a. Now what is this? F dash, f double dash and f triple dash are derivatives. order of the derivatives. Okay, yeah. Now, so in general we can write f of x can be written as sum over x minus a whole to the power n divided by n factorial into nth derivative fn of a. So this fn represents the nth derivative of a. Now let's do a very simple problem. That means I need to expand the function f of x equal to sin x at x equal to pi by 2. Now immediately once you get the question, kindly please write down until you are familiar with the expansion. F of x is equal to f of a plus x minus the point where we have to define x minus a by 1 factorial into f dash of a plus x minus a whole square divided by 2 factorial into f double dash of a plus x minus a cube divided by 3 factorial by f triple dash of a. Write the formula as much as possible. Write it. Okay. Now we need to expand this function f of x equal to sin x at x equal to pi by 2. Now f of x, what is the function? F of x is equal to sin x. So this is the function. Now what is f of pi by 2? F of pi by 2 is sin pi by 2, that is 1. Now next one is the first derivative of f of x, that is f dash of x is equal to sin x derivative cos x. Cos x at pi by 2 is 0. F double dash of x minus sin x, that will be minus 1. Then f triple dash will be equal to minus cos x, again it will be 0. f4 equal to cos x, that will be again sin x, and this term will repeat in this fashion. Okay, now we need to substitute for these things. So f of x is equal to f of a plus x minus a by 1 factorial into f dash of a plus x minus a whole square by 2 factorial into, so you can write what is f of a. F of a is given as 1 plus x minus a by 1 factorial, and f dash of a is again 0, so you need not write that, but still for the time being we will write. So now you need to the second term, x minus a whole squared by 2 factorial into minus 1. Right, now one thing that you need to write again is a is equal to pi by 2. So our f of a becomes, or f of the function f of x will become 1 plus this term is 0 plus x minus pi by 2 by 2 factorial whole square with a minus sign. Okay, plus again that will be the 0 term, so here you will have x minus pi by 2 whole to the power 4 by 4 factorial, so it goes on. So Maclaurin's series, So Maclaurin series is the expansion at a point a equal to 0. In the case of Taylor series we had at x equal to a, this was some arbitrary point, but in the case of Maclaurin series the point is well defined, that is a equal to 0, or you can write the Maclaurin series is nothing but Taylor series at x equal to 0. This is also fine. So how will you write your f of x? F of x is equal to f of naught, instead of a you will write naught, plus x minus a here. So here a equal to 0, so x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0. It goes on. Okay, now for example we will write let the function f of x be equal to e to the power minus x. Now function is given, we need f of 0. F of 0 is equal to e to the power 0, that is 1. Now the first derivative f dash is equal to minus e to the power minus x, then f of 0 or f dash of 0 equal to again minus 1, then f double dash is equal to e to the power minus x, because minus 1 gets cancelled, so f double dash at 0 equal to 1 again. Now f triple dash equal to minus e to the power minus x, f triple dash of 0 again is equal to minus 1. So it goes on. So how will you write the function? So for function we need this one. So e to the power minus x can be written as 1, that is f of naught, that is 1, plus x times f dash of 0, f dash of 0 is minus 1, so minus 1, by here 1 factorial is there but we need not write, okay, plus here x square by 2 factorial, into f double dash of 0. What is f double dash of 0? Again that is 1, again plus x cube by 3 factorial into f triple dash of 0, that is again minus 1, and it goes on. Now let us write e to the power minus x equal to 1 minus x plus x square by 2 factorial minus x cube by 3 factorial. The next term will be, this is minus plus minus, again it will be plus, it will be x to the power 4 by 4 factorial, and the next term you can say it would be minus x to the power 5 by 5 factorial. So this is the expansion of e to the power minus x at x equal to 0. This is Maclaurin's series. Simply we can write it as sum over n equal to 0 to infinity, because it is an infinite series, minus 1 whole to the power n, x to the power n divided by n factorial. Now why is this minus 1 whole to the power n? Is because you have alternate minus and plus. Whenever you have alternate minus and plus, your summation should contain minus 1 whole to the power n. Please remember, whenever we have alternate plus and minus in the series, then your summation should contain minus 1 whole to the power n. Okay. So for sin x, sin x, what is the term that you are getting is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial, etc. This is the answer that you are getting for sin x. Now how will you write it in summation form? That is sum over n equal to 1 to infinity minus 1 whole to the power n plus 1. This is because alternate plus and minus. There should be always minus 1 whole to the power n. Okay, that this term you have to check and write down what it could be. Now here x is there, x to the power 3, x to the power 5. So x to the power 2, even numbers are missing. So immediately you can write x to the power 2n. This is even, add 1. Okay, divided by whatever is in the numerator, or this should be 2n plus, no, it should be 2n minus 1, 2n minus 1 whole factorial. This is factorial n, because we are starting from 1, right? So if n equal to 1, it should be 1, and 2 into 1 minus 1, that's why, and minus 1 whole to the power n plus 1. Fine. Yeah. Similarly, our when you do it for cos x, the terms would be 1 minus x square by 2 factorial, then minus, there should be plus x to the power 4 by 4 factorial, then again minus x to the power 6 by 6 factorial. Okay. Here we can write the sum over n equal to, let us write first the x terms, x 2n. This also we can write it in the form of n, so no problem. 2n divided by 2n factorial, this is fine. So n 2n value should be equal to 0, so n equal to 0, but alternate plus and minus is there, so minus 1 whole to the power, the first plus term goes here, so this should be even, right? Minus n. Okay, that's fine. The question is log of 1 plus x. I need to find the Maclaurin's series at we need not define at x equal to 0. This is understood. Okay, now let me write the function f of x as log 1 plus x. Okay, now its first derivative would be equal to 1 divided by 1 plus x. No need to differentiate again because it's only single term. So f double dash will be equal to the minus 1 times 1 plus x whole square, and the third derivative will be equal to, here minus 2 will come, so minus 2 into minus 1, that is plus 2, divided by 1 plus x whole cube, f 4 dash, or 4 you write, that's equal to minus 3 would come, minus 3 into plus 2, that is minus 6, divided by 1 plus x whole to the power 4. Now we need the function at x equal to 0. So at 0 it is 1, at 0 it is minus 1, at 0 it is 2, right? Yeah. At 0 it is minus 6. This is 2 only, plus 2. So let us write the function f of x. F of x is equal to log 1 plus x equal to what is the function f of 0, that is log 0, that is 0. Before that, let us write down the formula first. What was the formula of that f of x equal to f of naught plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0, and it goes. Now let us equate all this. Now f of 0 log of 0, that is equal to 0, so need not consider. So x into f dash of 0, that's 1 into 1. Then the next term is minus 1 into x square divided by 2 factorial into f double dash of 0, that's we already took it into consideration. Fine. Now minus plus x cube by 3 factorial into f triple dash of 0, where is f triple dash of 0, that is 2, plus x to the power 4 by 4 factorial into 6 with a minus sign. So here the first term is plus, second term is minus, third term plus, fourth term minus, and it goes on. Now let me write this as x minus x square by 2 factorial is nothing but 2 plus this is x cube by 3 factorial is 1 2 into 3 into 2 minus x to the 4 by 4 by 1 2 3 4 into 6. Okay, it goes on. So this I can write it as x minus x square by 2 plus this 2 and 2 get cancelled, so it becomes x cube by 3 minus this x to the power 4 and 2 times 3 is 6, so it get cancelled with 6, so x to the power 4 by 4, it goes on like that. Okay, so I can write log 1 plus x is equal to x minus x square by 2 factorial, sorry, not 2 factorial, 2 by x cube by 3 minus x to the power 4 by 4, etc. Now at x equal to 1, how can we write this? This log 2 is equal to at x equal to 1 means log 2 equal to, so 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, the next term will be plus 1 by 5. So this is the value of log 2. It goes on. Okay. Okay. Now based on this, let us do a problem from summation and series. The question is a series in a coordinate system. This is the coordinate system where this is the x-axis, this is the 0. Okay, at each point, that is at a distance a, series of charges are being kept plus q. This is another distance a minus q, another distance a, again plus q, another distance a minus q, another distance a plus q. So it goes on. Okay, so all these distances are unit distances. The unit is a with plus and minus q charges placed in the every alternative distance a. Now you are asked to find the potential at v. Find the potential v at the origin. Let me write this as origin. So at this x equal to 0, you have to find out the potential. Now formula v is equal to kq divided by a, right? Kq divided by a due to the first charge, or let me write v is equal to 1 by 4 pi epsilon q divided by r. This is the formula. So this 1 by 4 pi epsilon is k, q divided by a due to the first charge. Now plus k q divided by a with a minus sign, because I have kept a minus charge here. But here the distance is a plus a, that is 2a, plus again this is plus charge k q divided by 3a minus k q divided by 4a. Fine. Now this will continue. Now this is equal to, you can take out the common things, kq by a, if you take it out, it becomes 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, etc. Right. Now this was nothing but log 2, all these things. So v is equal to kq by a log 2. If you don't remember, this 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 is nothing but log 2, then you cannot solve this problem. So that's why summation and series are important. So this is how our CSIR and GATE competitive exams questions get twisted in this way. We say the problems are a little tricky. So this makes the CSIR problems tricky. Okay, binomial series. Binomial means there are two variables. These two variables can be head, tail, like yes or no. Okay, so depends on what are the conditions that we have. Now we can expand the binomial series as x plus y whole to the power n is equal to, in the form of combinations, so nc naught, x to the power naught and y to the power n. Okay.
Sir, can you repeat? You were not audible for some time. Yes, it's only this thing. After two variables, your voice was.
After two variables, it can be either head or tail, or yes or no. Anything, probabilities like favorable probability and unfavorable. These are examples of two variables. Okay, so x plus y whole to the power n, you can write it as in the form of combinations n c naught, x to the power naught, y to the power n, plus then the next term would be here n c 1 x to the power 1 y to the power n minus 1, and it goes on. Okay, and in the form of summation you can write x plus y whole to the power n is equal to sum over let me bring in a quantity r equal to 0 to n up to n. Okay, ncr x to the power r into y to the power n minus r. So this is x plus y whole to the power n. Now you can have any restrictions on x and y so that you get the final output. For example, if you put y is equal to 1, then you can write x plus 1 whole to the power n, or 1 plus x whole to the power n. Then how can you write is this as nc0 x to the power 0, y you need not consider because y to the power anything is 1 because y is equal to 1. Then plus nc 1 x to the power 1 plus nc2 x to the power 2 plus, and it goes on. Now nc naught is 1, so x to the power 0 1, so 1 plus nc1 is nothing but n into x to the power 1. nc2 is, what is nc2? n into n minus 1 divided by 2 factorial nc2 into x square plus nc3 would be equal to n into n minus 1 into n minus 2 divided by, this is 2 factorial, okay, this is 3 factorial into x to the power 3, and it goes on. So this is for 1 plus x whole to the power n. Similarly you can write it for 1 minus x whole to the power n. What you have to change is change the coefficient, that is x to the minus x, then it would become 1 minus nx plus n into n minus 1 by x square. Here you need not change anything to factorial. Again now you have minus term because x cube will give you minus, so n into n minus 1 into n minus 2 x to the power 3 by 3 factorial. So this is 1 minus nx, but usually you stop by 1 minus x whole to the power, you write it as 1 minus nx, and you remove all these terms because these are negligible terms which contribute very least to the, see this is the, look at the order, it will contribute less. Okay, that's why we write 1 plus x whole to the power n as 1 plus nx sometimes while solving some problems based on this order. You write it as, even in electromagnetic theory or special relativity, you write 1 minus x whole to the power n as 1 minus nx. Again you can write 1 plus x whole to the power minus n, this would be equal to 1 minus nx plus here just change n to minus n, so this will become n into n minus 1, so that means n plus 1, so n into n plus 1 x square divided by 2 factorial. Here 3 terms would be there, so definitely you will have minus, so minus n into n plus 1 plus n plus into n plus 2 divided by 3 factorial into x cube. One more thing you can write 1 minus x whole to the power minus n. Again this is 1 plus nx plus n into n minus 1 by 2 factorial and the x square term as it is. Again there will be plus because here 1 minus will come and the 3 terms each one contributing to minus 1. So 3 plus 1 4 times minus, that is again plus. So n into n plus 1 sorry, it will not be n plus 1, it will be n minus 1 into n minus 2 divided by 3 factorial and cube as it is. So these are the things. Please remember the formulas, that is 1 plus x whole to the power n, 1 minus x whole to the power n, 1 plus x whole to the power minus n, 1 minus x whole to the power minus n. If you remember this formula, it is best. You just need to substitute each one. Here the question is expansion of tan inverse x. Now immediately how will you expand this? That's a question. Now the first derivative of the tan inverse x, tan d by dx of tan inverse x equal to 1 divided by 1 plus x squared. So this is what we know. And now just integrate on both sides with respect to dx. What you get is tan inverse x equal to integral 1 divided by 1 plus x squared dx. Fine. Now so this is 1 plus x square whole to the power minus 1, 1 plus x square whole to the power minus 1. But we know 1 plus x whole to the power n is 1 plus nx plus n into n minus 1 square by factorial plus n into n minus 1 n minus 2 x cube by 3 factorial. Remember this one, okay? Don't remember that it is minus n. Later we can just substitute for minus. Okay, so 1 plus x whole to the power n is 1 plus nx plus n into n minus 1. Okay, fine. So here let us put n equal to minus 1 here. So and what is x? X is equal to x square and n equal to minus 1. So let me write it as 1 plus n is minus 1 into x is nothing but x square. First term is ready, I mean second term is ready, plus n is minus 1, minus 1 minus 1, that is minus 2. So minus 1 into minus 2 divided by 2 factorial, and this x is nothing but x square whole square plus let us write that the last term also. So minus 1 into minus 2 into minus 3, because n minus 1 minus 2 also will be there, divided by, this is 3 factorial, into this is x to the power 3, so x square whole to the power 3. Okay, it's not very difficult. Okay, so 1 minus x square. Okay, fine. Now this is minus minus plus, so 2 by 2, that is gone. It will be x to the power 4, so plus x to the power 4. Then the next term, minus would be there because 3 terms are there, so x cube, so x to the power 6. That 2 3 has gone, so we need not worry. Now this we understood, so it goes on, right? But we didn't get to our formula because we have to integrate this now. So tan inverse x is integration of 1 minus x square plus x to the power 4 minus x to the power 6, etc. Now if you want, you can continue writing like this, right? The next term would be plus x to the power 8 and the whole, etc. up to dx. Now what you can do is integrate. X integration is, sorry, 1 integration is x, here x cube minus x cube by 3 plus x to the power, this is 5 by 5, this would be x to the power minus x to the power 7 by 7, then plus x to the power 9 divided by 9. Now we have got this formula. This is nothing but what? Tan inverse x. Tan inverse x is nothing but x minus x cube by 3 plus x to the power 5 by 5, etc. So this is what is the application of binomial expansion. If you just sit with this formula, you can go in, you cannot go anywhere. You know that tan inverse x is equal to integral 1 divided by 1 plus x square dx. This will be as it is, cannot move forward. This is very important in analytical functions. We will know how important it is when we are doing solving problems there. Relativistic correction to kinetic energy. Okay, so we can write the mass is equal to gamma times m naught, where m naught is the rest mass and the gamma 1 divided by under root 1 minus v square by c square. So what we can write in terms of the energy, we need in terms of energy, so we can write E is equal to gamma E naught, right? So gamma is 1 divided by under root 1 minus v square divided by c square into E naught, or 1 minus v square divided by c square whole to the power minus 1 by 2 times E naught. This is what we know. Now one more thing we know, how can we write 1 plus x whole to the power n in the series form, that is nothing but 1 plus nx plus n into n minus 1 by 2 factorial into x square. Fine. Okay, one more term if you want, you can write n into n minus 1, but we need only the first order correction, so 3 factorial into x cube. Okay, fine. So what we have here, 1 minus v square divided by c square whole to the power minus 1 by 2. So here let us write what is x. X is equal to minus v square divided by c square, and n is equal to minus half. These two things please write down somewhere. Then start writing 1 plus n is minus half, so minus half, x is minus v square divided by c square. Now the second term, n into n is minus half minus 3 by 2, this is multiplication. Okay, Okay, we will write like this, minus 3 by 2. By 2 factorial we will write it as 1 by 2 into x square. X square is square of this, so v to the power 4, v to the power 4 divided by c to the power 4. Okay, fine. Now it's equal to 1. This is into multiplication, so minus minus, that is plus, so v square divided by 2c square. This e naught is there, okay, we will put it in the last term. So 1 plus v square by 2c square plus minus minus again, that becomes plus, so 3 by 8 v square, v to the power 4 divided by c to the power 4. Now this goes on, but we will stop from up to here, and we need e naught, that is nothing but m naught c squared. Now you need this particular term, the correction. This is first order correction, this is second order correction. Now that is 3 by 8 v square v to the power 4 divided by c to the power 4 into m naught c square, and here get cancelled. So what is remaining is 3 by 8 m naught v to the power 4 divided by c square. So this was the correction. Now when you put to the first term, second term, or the first term, you will get the rest mass energy m naught c square. This is the first term, and when you put to second term, what you are getting, just let us see, 1 by 2 v square by c square into m naught c square get cancelled. What you are getting is half m naught v square. This is nothing but the kinetic energy of the particle. Fine. If it is moving with some velocity v and it has a rest mass m naught, okay, so this is the rest mass energy, this is the kinetic energy, and this is the correction to the kinetic energy. There are two tests. This is testing the series based on whether it is convergent or divergent. So sum, if we are writing it as for n terms, so sum of n un, the general term, un represents the general term, that is limit n tends to infinity of any general terms, number of general terms, should be equivalent to, if it is equal to 1, then it is divergent. Okay, and if it is equal to 0, you can't say, or not possible to judge whether it is divergent or convergent. But if it is equal to 1, you can definitely say that it is a diverging one. Now for example, you can write S is equal to 1 by 2 plus 1 by 3 plus 1 by 4, 1 by 2 plus 2 by 3, 3 by 4 plus 4 by 5, etc. Now we want to know whether it is converging or diverging. So in general, you can write it as, this is, if it is first term is n, the denominator should be n plus 1, right? So n divided by n plus 1. Now we need to find this sum as equal to sum over n divided by n plus 1. Now how will you write this? N divided by n plus 1 can be written as n divided by n into 1 plus 1 by n. So n and n get cancelled, so it is 1 divided by 1 plus 1 by n. Now when n tends to infinity, what will happen to this value? This particular value will go to 0, and 1 by 1 will remain as equal to 1. So this is equal to 1. We can say that it is divergent. This is how we can do this. Okay, now some another example we can take. Sum over n plus 3 divided by some n square plus 10n. So similarly, what we have done with the previous case, you have to take n, try to put this n which is tending to infinity into the numerator form. So n divided by 1 plus 3 divided by n divided by, again you can take this n square out. N square, when you take it out, it becomes 1 plus 10 by n. So so it's 1 by n. So now when you put n equal to infinity, this 1 by n will go to infinity. I mean 1 by n in the denominator infinity, it will be nearly equal to 0. That means it is going to 0. So we cannot say cannot have what to say, don't know, we don't, like, it's not possible to tell. Okay, now this is using convergent and divergent test. The normal sum we are doing. Now another kind of test is D'Alembert's ratio, that we can see how it is being done. D'Alembert's ratio for convergent or divergent test. Convergent or divergent test. Same as before, but here we have one more criteria. The process is same. The sum is equal to sum over n of any n general terms. Then D'Alembert's ratio, it is given by rho. Rho is the D'Alembert's ratio. Rho is given by when limit n tends to infinity, un plus 1 divided by un. When limit of this un plus 1th term divided by the previous term, if it is equal to, there are three conditions. If it is less than 1, it is convergent. Okay. If it is greater than 1, it is divergent. That you can see it from here itself, right? If it is moving higher up, it is divergent. If it is coming down, it is convergent. Now if it is equal to 1, then cannot say, cannot have any judgment on the conversion. Now let us take an example. For example, sum over n 1 by n factorial. So how it will be? 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, it goes on, right? So nth term will be equal to 1 divided by n factorial, and un plus 1th term will be equal to 1 divided by n plus 1 factorial, this is n plus 1 in bracket. Now when limit n tends to infinity, un plus 1 divided by un is nothing but 1 divided by n plus 1 factorial divided by 1 divided by n factorial. So is n factorial will go up divided by n plus 1 factorial. Now that is n factorial divided by n factorial into n plus 1. Do you agree with this? N factorial get cancelled, 1 divided by n plus 1. Now this n is tending to infinity, so this is nearly equal to 0. So this delta is equal to or nearly equal to 0, which means less than 1. We have a convergent series. Okay. Yeah. Let us try to do this problem. Sum over n 2 to the power n divided by n squared. Now using the D'Alembert's ratio, we can write limit for n tending to infinity un plus 1 divided by un is equal to so we need to write 2 to the power n plus 1 divided by n plus 1 whole square. This is the first term, okay, divided by un will be 2 to the power n divided by n square. Now that you can write it as 2 to the power n plus 1 divided by n plus 1 whole square into this one will go to the numerator, n square divided by 2 to the power n. Now just a few simplification. 2 to the power n plus 1 can be written as 2 into 2 to the power n into n square divided by n plus 1 whole square. You can write it as okay, let that be n plus 1 whole square itself for time being, by 2 to the power n. Let us try whether if it can be simplified. So this 2 to the power n, this goes 2n square divided by n plus 1 whole square. So this becomes 2n squared divided by n plus 1 whole squared. Now you can do one thing, keep the numerator as it is, and this is n square plus 2n plus 1, and now from the denominator please take the n square outside. So 2n square into n square into 1 plus 2 by n plus 1 by n square. Now put this n tending to infinity here, and this n square and n square get cancelled. So this becomes 2 divided by 1 plus 2 by n 0, that is again these two terms becomes 0. So this is 2 which is greater than 1. So if 2 is greater than 1, that means your delta is 2 which is greater than 1. So it is a divergent series. See, integration test, we know the sum.
Sir, it is a test for divergent and convergent too.
This one. Which one? This integration test.
This is also for
divergent. This is for divergent.
This is also for convergent.
Divergent test. It is usually divergent test. It is. Yeah. So sum you can write it as sum over n un, right? This is the general form for sum. Now this instead of summation, you can also use integration from un dn, that is from 0 to infinity. This is where n tends to infinity. This is from 0 to infinity. Okay. What we will do the first question. Yeah. Fun. S is equal to sum over n 1 divided by n log n. We can use a natural log. 1 divided by n log n. So integral from where to where, 0 to infinity, 1 by n into log n. So this we can write it as 1 by n divided by log n. Same thing, right? 1 by n, I am just writing it in the numerator. Now the whatever is in the denominator is the derivative of, or in the numerator you are seeing 1 by n, it is the derivative of what is in the denominator. So integral dx divided by x is nothing but log x, right? Whatever is in the denominator, its derivative is in the numerator. So log x. So integral 0 to infinity log of log n. Sorry, no need of integration, only putting the limit 0 to infinity. Now if you put log infinity, it will become infinity. So it is a divergent. Okay. So now, okay, so that, yes, friends, before going to the next question, VK Lectures has got something for you. We are doing CSIR net classes for about 12 months, and we will have around 300 hours of class. And for PhD students, faculties and working students, recorded classes of our video will be given to you in the link, YouTube link mainly. And in the this 12 months duration, we will be solving around 3000 problems in the class, and we will almost have around 60 test papers. Weekly exams will be conducted through Google form, and we will also have question solving sections after the exam. Class timings will be from 7 to 8:30 p.m. from Monday to Friday, and this will be conducted online through Google Meet. The class will have the course will have the fee structure of 20,000, and the first 5 admissions will be giving 40% discount. That means the first 5 admissions need to pay only 12,000, and the next 5 admissions will be given 25% discount, which is 15,000 rupees. Now, what extra materials VK Lectures is providing you is around 50 plus ebooks for reference, and if students require only some particular subjects like quantum mechanics, you will be given 40 to 50 lectures of quantum mechanics, and the regarding test papers and corresponding materials will be given. And for lecture series, that means per subject you may have to pay 3,500. And yeah, so that's about our course. For details you can contact, either you can use our Gmail, or you can use our Telegram channel or WhatsApp channels for that. Thank you, and we will see the next question.